let's move forward and talk some more details. See, there are two types of directions. First one is clockwise and second anti-clockwise. See, what do I mean by this clockwise? All of you might have seen the hands, second hand, minute hand and hour hand of a clock. All of these hands move in this direction. That means like this. This direction is known as clockwise, and opposite to this direction is known as anti-clockwise direction. Now we defined angle in the last class. See this thing, this measurement here is known as angle. There is a conventional way of measuring this angle. We measure this angle in anti-clockwise direction. That means if we measure any angle in anti-clockwise direction, in this direction, we take that angle as positive, and if we measure in clockwise direction like this, we take that angle as negative. I hope it's clear. Anti-clockwise direction, angle is taken as positive, and clockwise direction, angle is taken as negative. Now see, let me draw here Cartesian plane. Cartesian plane is nothing, it's a two-dimensional plane. Cartesian plane. See, first of all, let's draw a horizontal line like this, same as the way we defined angle. Let's take this point, and second line just superimposes this first line, just superimpose it. See, now let's move the second line. There are 2, 1, 2, both the lines are here at initial stage. Now let's keep them here fixed at this point and move the second line. For example, we take it to this position now, this. So this much amount of angle we have covered, this, and in which direction? In this direction, anti-clockwise direction. Maybe this angle approximately it will be 45 degrees. Now let's move it further and make it a vertical line over here, this. Now we have covered this much amount of angle, this, and this angle is 90 degree. We have covered 90 degree. Let's take this line over here. Now we have covered this much angle. Maybe this angle be approximately 120 degree, and when we move the second line, and it will superimpose this side of the line. Now we have covered this much angle, and this angle all of you should know it is 180 degrees. If we move further and try to bend it like this, now we have covered this much angle, this much, maybe it is 220 for example, and let's move it further and take it over here, this. Now we have covered this much angle, this much. This angle is 270 degrees, and when we take it back to its original position, we have covered 360 degrees. So basically, let me make it in a new slide. We have divided this in 4 quadrants. Basically, this is first quadrant, second quadrant, third quadrant, and fourth quadrant. Starting from here, first this line was here, this much was angle, this angle was in first quadrant, and till here we can reach a maximum of 90 degrees. And if we want to move to this side, we will move greater than 90 degree, and up to this side, for second quadrant we can go at a maximum of 180 degrees, and still we can go to this third quadrant and at max we can go to 270 degrees, and in fourth quadrant we can move back to the original position and we will be here from where we have started, and we have covered the angle 360 degrees. And now if we still move further, now till here, till this point we have covered 360 degrees, and now if we still move further, its angle, now for example the line is now here, making one revolution we again move this line to this point. For example, it's 60 degree. Now we have covered first this 360, now plus 60 degrees. So 360 means one complete revolution starting from this point and back to this point. After that it is plus 60. Plus why? Because we have moved in anti-clockwise direction. If I'll say you draw this angle 360 minus 20 degrees, that means first we have to draw 360, that means we'll go like this and move the original position like this. Now it is minus 20. Minus means, I have said that convention way of measuring the angle, the positive direction is this anti-clockwise, but it is minus, so we have to move back 20 degrees like this. Now the line will be here, for example like this will be the line. It's not straight, so this much amount will be this angle 360 minus 20 degree. I hope it's clear. In the last class we saw these trigonometric ratios: sine, cos, tan, cosec, sec and cot. Now let me discuss a bit more detail about this. Let's take an right angle triangle like this. This is right angled over here, B, A, C. Let's take this r theta. This angle is theta. Now as you know, sine is our trigonometric ratio, and this theta which we substitute here, this is the input for this sine. That means this sine is our function. Function you can understand by a machine. For example, this is a machine and we put some input, and input here is angle, this theta. This is our input, and this machine, when we input our data, this will give us some output, that means a result. This sine can be considered as a function. Function may be considered as a machine in which we put some input, and input here is our angle theta, and we get some value output. For example, let us take this theta as 45 degrees. For example, this theta is 45, this angle here over here is 45 degree, and I am interested in finding the value for sine of 45 degree. Now what is the definition of sine ratio? It is this perpendicular, because side opposite to this angle is perpendicular, by hypotenuse. This is our hypotenuse and side adjacent is base, so it is AB by this hypotenuse, that is AC. Now if I want to decrease this angle, now I want theta as 60 degree. Now this angle, I have to increase this angle. Increase means, see, this is 45